some more of the board. Okay, if there's anyone out there listening, this is short, very short live stream on. I'm just going to try and fiddle with the camera to make it get as much of that board as it possibly can. Oh, there's 3 people. Best thing you can do is sign in. Can you sign in and sign in on the chat so I know who I'm talking to? It makes a big difference if I'm talking to whomever, so I know who's my target audience out there. I'm going to fiddle around with the camera. I'm going to edit this all out. So you can see if I plug on my house. It's very exciting. Why is that? Is that like that? Hey, Harley, good to see you. Good to see you. Hope you're doing well. I mean, it's been a crazy, crazy week. I don't know if you followed what happened to year 13s. I mean, Jesus God. Yeah. Nevertheless, year 12s are in front of me, so year 12s is what I'll deal with. The exercise I set you was 7B, which I don't actually have in front of me. I'm just going to go and fetch that. I picked up the wrong book. I've got the year 2 book on the wrong book. I'm back in just a moment. So what I want you to do is pop questions in the chat box, and I definitely want you to be all logged on to the chat box so you can ask me questions, because like obviously I can talk to you, but you can't talk to me. So if you're in the chat box, you can talk back. There's 6 of you, so like the only one who has owned up to his existence is Harley. If you don't have a Google account, get one. I mean, seriously, we're going to be doing this for some time. Okay, I've got the year 1 book now, so that's fine. I'm going to be honest, has made this topic hard for you. Yeah, I mean, it's hard. It's already hard, given the fact that it's critical regions. People find critical regions difficult. Yeah, I can go through question 2. I will go through question 2, don't worry. I've got my calculator here as well, so that's not going to be a problem. You just mind if I just take a couple of minutes just to get everyone in? And can I get more than Harley just signed in the live chat, please? It's kind of pointless me doing a live chat to one person. So Harley, yes, we'll definitely go through question 2. Hey, Demetrius, it's a pleasure to see you. I hope you're doing well there. So the question I'm being asked is 7B. As I said, I'm just going to hold fire on that for the moment. All right. Rahat, brilliant. Rashida, excellent, 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 excellent. Do you want us to do all 7B by the end of the lesson? Ideally. But realistically, given that people are struggling, it's not going to happen, is it? All right. So you just do the best you can and send me a picture of it. That's a fair shout. All right. I mean, if you're at the point of doing question 2 on 7B, then obviously you're not going to finish the whole exercise, are you? It looks like I will have to start each lesson with a live stream then, because it looks like doing it from distance isn't working so well. Okay. All right. Okay, there's enough people to make it worth my while starting this question off. So the question goes, a test statistic has binomial distribution B at 10 and P. So you go X, look at my hand, how exciting. X is binomially distributed 10. And what goes where P goes? It's the null hypothesis, so point 2. I hope that makes sense to everyone. So that's your starting of your null hypothesis, right? We know that we're looking, it's a one-tail test because the alternate hypothesis says this, H1, is that the probability is greater than 0.2, which makes it one of the harder ones to do. What am I going to do now? I'm going to either use the table, and you can find the table printed on page 102 of your textbook, or use your calculator. I'm going to demonstrate the calculator method. Hey, Zeran, good to see you, my dude. So what I'm going to do now, and the tapping you can hear off screen is me typing into my calculator. In fact, it might be handy if you could see what I was doing. Maybe, yeah, I don't know how well that's going to show up. Push that there and do that there. That's a shot, isn't it? But then I don't know what I'm doing. Sorry. I mean, I'm going to rethink that. I'm going to say what I'm doing. Let's just sing along with Uncle on this. Right. So if you go to menu, turn the damn thing on for a start. On. God damn it. There we go. Hitting it works. Percussive maintenance. Let's stop working. Just my luck. Just as I need my calculator to work, it's bloody turn off. Okay, cool. Here's how you do it. You go to menu. Yeah, I'm on. Good boy. So you go to menu. You go to 7. You go to binomial CD. Okay, and I know Zeran, you've already done this, but just be cool, so everyone else is catching up with you. And then your calculator suddenly turns off again. Menu 7, binomial CD. Press number 1, and you're going for list this time, not variable. And because your values go to 10, that's what you're going to insert in the table. Yeah. So your first number will be 0. Press equals 1. Press equals 2, and you get the idea. I'm not like that woman on those endless videos that just keeps on telling you the same thing over and over again. But what you should have is 2 columns, X and B, and you filled in those 2 columns with the left-hand side being 0 to 10 and the right-hand side saying nothing. But yeah, if you press down on your calculator, when you're in that menu, a whole 3 other options come up. The first option of those is binomial CD. And you're used to using binomial CD, and I don't know why you're having a panic attack about it. Or actually, no, because you weren't in last lesson, were you? No wonder you're worried. So go to menu, go to 7, and then pick the down arrow. There's a crosshair in your calculator, isn't there? Right, just under the screen in the middle. Press down. That'll get you in. So once you've done that, press equals. What are you going to say then? The n is going to be 10. Why? Because there's 10 events. And the probability is 0.2 because they tell you in the null hypothesis the probability is 0.2. And you now get a table eventually. My calculator is absolutely glitching out on me. What I'll do is I'll try and get it to do something sensible. I mean, good luck with that. Sorry. So yeah, I do that, and you get a bunch of numbers. And the numbers you should get, the first one that's bigger than 0. So we're looking for 95% here. The first one that's bigger than 95% is a 06972, yeah, at 4. So at 4, it tells you 0.9672, if I remember correctly. If I'm wrong on that, sorry, I'll put that up so you can see it. If I'm wrong on that, let me know. But it's something on those lines, right? Do I pick that as my critical value and critical region? No. Because that's just telling me the probability of being less than or equal to 4 is 96%. But I want to have the top 5%. Yeah? Good. Yeah? I want the top 5%. So I'm not looking for the probability of being less than or equal to 4. You see my inequality is going the wrong way compared to my hypothesis. So what does it do? I just switch it around. I say the probability of 4 is the same as 1 minus the probability of 5 in that way. Yeah? So what you've now got is that 5 is your critical value, and 5 or more is your critical region. All right. So you've got to remember that every time you're doing a greater than, when you're doing it on your calculator is doing it as a less than. Hey, Wilson. And what you're trying to do there, what you're trying to achieve, is to find out what number is the first number and what numbers would make you reject the null hypothesis. So the number that is the first number that would make you reject the null hypothesis is actually 5, even though that 4 is the 0.9672, because that's talking about being less than, and you want to be greater than. And the way to move around from a less than to a greater than is do a 1 minus, and that will swap your inequality sign around. So 5 is your critical value, and 5 or more is your critical region. So what is your critical region if I spelled it out to you? 5, 6, 7, 8, 9, 10. All right. I hope that makes sense to people. Can you pop a comment in the live chat if that's not making sense to you and you need me to repeat it, or you've come in late or whatever? Does anyone need it from the beginning? Because that's fine. If you don't need it anymore, like you understand how 2 works, you feel free to drop out of the chat, because I'm not going to stay here like for the whole of the rest of the lesson, but I will stay here for a while until people fully understand question 2, or if they've got any other questions, they can ask it now. And I think from now on, I'll live stream all of them. So I don't think that little tappy message thing is going to be, I mean, it's good to start. It's good to have a register. That's great. I'm glad we got a register, but I just don't think that's teaching. I don't think you're learning any damn thing. So put a comment. Can I repeat, please? Yes. Can I do question 6? Yes, I probably could. I will check that in just a moment. So what I'm going to do, Council, you might want to go up and get a drink or something. So I'm going to repeat first. So 10 is a critical value. Yes, it is. Anything above 5 is, including 5. So 5, 6, 7, 8, 9, 10 is a critical value. However, the critical value itself, yeah, is from 5 to 10. So this is critical. Every one of those is critical value, but the edges, which was the proper name for critical value, is 5 is the lowest and 10 is the highest. So yes, Rashida, you're absolutely right. Your two borderline numbers are 5 and 10. Well done. Really great. So you clearly understand this, but I already knew you understood this. So you understood last lesson. Right, so I'm going to repeat for benefits of Fazana. Can anyone else who doesn't understand it just own up in the comments, because then I know who I'm talking to and I can insult you personally, I guess. Okay, cool. I need to wash my table. I've not, seriously, no preparation for this at all. Normally, like, everything is beautiful. It's a pot of flowers. There's not a pot of flowers, there's never a pot of flowers, but Okay, cool. So question 2 says, test statistic as binomial distribution 10p. So we can write x squiggle binomial 10 and 0.2. And you might be wondering where the 0.2 came from. It always comes from the null hypothesis if that's not clear. Yeah, we rely on the null hypothesis. We're basically saying we're going to assume the null hypothesis is true until we don't believe it anymore. The alternate hypothesis says this. So we know we're looking for a one-tail test. Yeah, it says this. So we know we're looking for a one-tail test. If it was a not equal sign, the one that goes equals with a slash through it, the one that looks like this. I'll stop doing that. Then, hey, pleasure to see you, Dante. If it looks like this, then you've got a two-tail, but there's one tail here. Yeah. What I need to do is get a habit, or just maybe blue type the whiteboard. Yeah, I'm more than happy to. I'm going to do 6, then I'm going to do 3. It's on my to-do list, don't worry. So, what are we saying? We have got a one-tail test, and we want to find the critical region. And this was our distribution here. Let's put it there. X is binomial 10 and 0.2. And because you're doing a because you're doing a critical region, then you need to do the list function in mathematics of your calculator, which is a distribution, which is 7. It won't immediately come up. You need to press the down button on your calculator and then pick binomial CD. Yeah. And then it'll give you 2 options. Yeah. And the one you pick is list. Once you've got the list, what you need to do is type in the number 0 to 10. Why? Because it's from 0 to 10. It's as simple as that. Once you've done that, press equals 1 final time, and it will give you the option to submit the numbers, which are going to be, in your case, 10 and 0.2. You'll then get, eventually, it'll take a little while, you'll get a list of numbers in the second column. Because we're looking for a greater than, yeah, because we're going for a greater than, we will need to pick a number that is above 0.95. Why? Because it's a 5% test. So you want to be in the top 5%. So 95% below it and 5% above. If you remember how your calculator works, it always goes at this point, it's this probability or everything less than it. And you want a greater than, and that's the opposite. If you do that on your table, you will get that 4 on your table is 0.96 blah, 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 blah. I can't remember exactly what it is, and my calculator is glitching on me. That's not the answer, because that's the probability of being less than 4. Less than or equal to 4, rather. But you want to be greater than. That's what's said in the question. So you flip it on its head by doing, well, being less than or equal to 4 is the same as being greater than or equal to 5. Yeah? And this 96% then becomes 4%, which is much closer to the top 5%. Yeah? So your critical values are 5. Well, it'll be 10 as well. I'll get onto what Rashida was talking about in the live chat in just a sec. It's 5 and greater. And the reason why we can say the critical values are 5 and 10 is because obviously 10 is the largest number you could possibly be. So any number between 5 and 10 is the critical region. And the critical values are just the edges of the critical region. So I hope that makes sense to you. All right. Next question was 3. Let's have a look at that. I mean, question 3 is almost identical. So let's just quickly, let's do that. So if you're struggling with 2, even 3, maybe just turning your eye to 3. No, my pleasure. Should be okay. I might need someone, my calculator is literally dying on me. So I might need someone to do sums for me in a mode, but other than that, shouldn't be too hard. Again, it's a one-tail test. How do I know that? I've got a inequality rather than a not equal sign. So you can immediately go, this is a one-tail test. X is binomial. I will move my hand. I can see it's in the way. With 20 and 0.15. All right. How have I got those numbers? Because the null hypothesis is 0.15. All right. Yeah, I'm going to probably, the thing about posting up a live stream is I probably want to trim out the minute where I've got actually, do I want? Okay, just basically, if you watch this live stream again, just there is a minute of me just faffing around with the whiteboard, picking up my calculator and doing all stuff like that. This is not a prepared one, as you know. I was going to do one on Monday. Doesn't matter. I mean, I think I'm going to, as I said, I'm going to do one of these every lesson now. I just think it's better. Okay. In any case, that's what we've got. Again, it's the same process again. All you need to do is go table, list, just like you did before. 0.15 isn't given as one of the tables in the formula book, not that I can see anyways. So you're going to have to do this on your calculator. And you need to find the first one, the first number that's less than 5%, but very close to 5%. I'm actually going to try and do this with my beat up calculator and see what happens. Okay, so here you've got, 20 numbers. I mean, realistically, you're not going to need all 20. And also equally realistically, I'm going to blow this thing up in a minute. That wasn't a threat, by the way. It wasn't the calculator. It's literally glitching out at me. This is going straight into the bin afterwards. So this example does not work. Why are you being like that? All you've got to do is your job. I mean, who is doing their job these days? Anyways, you don't get binomial CD. Why? I mean, you can't just leave a line like that. You have to explain what you don't get about it. The only value is 0. You might be right. I'm going to check solutions in a moment. Can you? You can't really. This is the problem, and I can't either. It's a bloody calculator. That seems to have killed it completely. Actually, hitting it that hard. Okay, cool. What I'm going to do is I'm going to just check that answer. If it isn't 0, we're in trouble. But I suspect it would be. Council generally knows what he's doing. 7B. Yeah. Okay, cool. So what must have happened is that the only number that's below 5% on your list when you do the calculator, 5% significance level means that to reject the null hypothesis, you've got to have an event that would only happen 5% of the time. Yeah. So is that making sense now? Yeah. So level of significance just means this is how crazy you have to be before I'm actually going to change my mind. I'm going to reject the null hypothesis. Okay, and the way you do it is you make the list on your calculator and see, well, for critical regions anyways, you make the list on your calculator, and if you're a less than, yeah, you'll look at exactly what Zaran just said on the chat. It's less than 5%. Find the first one that's less than 5% that's close to it, and that's your critical region. If you want to be a greater than, then you go for the first one that breaks 95%, so it's above 0.95, and then pick the one above it for the reasons that I made earlier on in this video, namely the calculator gets things the wrong way down, round, right? So the other one was requested was 7, wasn't it? Was it 7? If it's bigger, yes. Basically, if it happens more likely than 0.05, that's not crazy enough to change my mind. Just remember it as if you're a stubborn old man and you have your beliefs and you don't want to change your beliefs unless the thing that happens is so crazy you can't reconcile it. Yeah. So like something happens at like 51 on chance. The first critical value is 7. For which one? How do you do the list again? Okay, so what you need to do is go to 7 for distributions, binomial CD, which you get by pressing the down button once to get that as an option. Pick list, type in your numbers. When you finish typing in your numbers, press the equal the second time. Are you doing question 3? The answer to that is because this time it's a less than, not a greater than. Yeah, if you look at the inequality tells you. Yeah. So we're having a look at number 7. Yep, Zaran doing a hell of a job in there. I mean, for next time, I'll have a calculator that works. So that'll be a lot more easy. You can just film the damn calculator. But yeah. Do 1 minus everything in the list. What are you talking about in which particular question? Oh, yeah, obviously. I mean, you know, they've given you a list of numbers on the side. So I believe that P is less than 0.15. Well, you haven't got any evidence for that. All it's asking you to do is find the critical region, Harley. What do I put? What do I DAP? What the hell is DAP? Yeah, for 3 counts, yeah. This 1 to 20. I mean, yeah, fine. I mean, press equals, yep. Press equals and substitute in the values for N and P. So 20 and 0.15. Right, so just on question 7, as I think Hauser asked for that one. The test statistic is either it's going to be something like that, the failure or the likelihood of failure of the mechanical component. I'm just going to use the exact wording they do, but it's that. Oh, you want 6, fair shout. Bear with, I'm just getting myself together on this. 7B, okay, got it. Question 6. So what have you got there? You've got for the first time a 2-cell test, and no wonder that. No, you've had 2-cell tests before. So 1% level of significance is 0.005, yeah, on both sides, because 1% split up is 0.01 split up, so 0.05 low, 0.005 high. Is that making sense? Is 6 the critical value? For what? No, question 6 he's talking about, Dante. I'm doing question 6. So you need to look at those numbers, 0.05 at both ends of the spectrum. So unfortunately, you will have to type up the table for this one. So I can't, yeah. So 1% gets broken up into 2 parts, 0.05, 0.005, yeah? Because each one of those is like 0.5%. Do the table as you did before, and it's only a 6, it's only a 10. So n is 10 and p equals 0.22. And this is an example of one of them where they're using it just to sell you the calculator, because 0.22 is not going to be given as one of the probabilities in the table. Yeah? Is 6 the critical value? As I said, no. Question 3 is 0, absolutely. Yeah? So once you've done that, you should look for, at the bottom end, the number that's closest to 0.005, but isn't bigger than it. Okay? And everything less than that number is your critical region on the low end. On your upper end, you need to be looking for the number that's closest to and is just bigger than 0.0995. However, so you want it just bigger than that. However, you can't pick that number. You need to pick the number that's 1 larger than it. All right? So that's the way you can deal with that. Write down the actual significance of the test. Write down what the probabilities of each of those values actually are in real life. So for 0.05, whatever number it actually was, so it might be 0.03 or 0.004, whatever it is, do it for that. Similarly here, for this guy, just do 1 minus whatever number you've chosen here. So it might be 0.00997 or something. 1 minus that. That would also give you another probability. You add the 2 probabilities together. I wish I could actually do the question for you, but literally my calculator's died. So I'm going to run through the mechanism again for that, just to make it hopefully clear to everyone. You break down the 1%. For question 6, you break down the 1% into 2 0.5%. Get your table, find the first one that's closest to 0.5%, but doesn't break it, so less than it. And then one that's closest to 99.5%, but is bigger than it. So it has to be bigger than it, but just bigger than it. Remember, for that second one, you have to add 1 to the value. So if this turned out to be, say, 7, you'd pick 8. Why? Because of that less than or equals to thing. Yeah? The calculator does less than or equals to, but you want greater than or equals to. So I'm hoping that makes sense to you. To find the actual value of it, what it says, he describes the actual significance level, you merely add the probability of this happening, which won't be 0.05 exactly, it'll be close, and won't be 0.005 here either, it'll be close. Add those 2 values together. So I hope that makes sense. Council seems as aimed at you. Let's see what you think on that. Question 4, is that 4 first one? 4A? Oh yeah, 4, just 4. Okay, cool. Again, it's the same thing. It's splitting up a probability distribution. If you want me to do notes, is it 0.05? I think you have to do 0 if that's all you've got. I'm just going to check the solution on that. I mean, I hear what you're saying. It's okay. The key word that makes it different is the probability in each toe should be as close as possible to 0.05, and that's your get out of jail free card. The method I told you is correct. Don't get it twisted, right? I'm telling you the right maths, but they've put an extra sentence in 6 to get around that fact that lets you be bigger than 0.005 because they said let it be as close as possible. Yeah, and that's the wording you need to look out for to get you out of the problem that you can't have 0. Okay, is that making sense? So whenever you see that wording, the probability in each toe should be close as possible to 0.005. That means they're giving you permission to be bigger than it as long as you're close to it. Yeah? So I hope that makes sense to you. but the method itself is not different. And you see when I do 4 very, very briefly, you'll see that it goes back to being my method. Yeah? Let's have, I'm looking at the solution in the back now. You said 0 would surely be the closest one, wouldn't it? Because everything else will be much larger. The question says 0. I'm looking at the mark scheme right in front of me. In the book I'm holding, it says 0, my dude. So it says 0 and 7 to 10 inclusive. And 0 is the closest one. So just go with me on that one, I'm afraid. I mean, if you hold in the book in your hand, you'll see that that's what the mark scheme says. So not the mark scheme, the actual solution. Yeah, is that all right now? So I'll do 4, and then I think I'll call that quits there, because we're heading up to about 30 minutes on this stream, and that's fine. But you know, we'll have to do an hour and a half on time stuff. The massive interesting. Okay, cool. So if you, yeah, I'm literally holding a textbook actually, and that's amazing. It's usually the other way around. Okay, I'm just going to write up 4, and again, I apologize. I will get a calculator. I also apologize for some bloody things on my table for some reason. Okay, cool. Let me just write it out. So you've got x is binomial on 20 and 0.4. H0 is 0.4. H1 is not 0.4. And the actual, so the level of significance is 5%. So you want to split that up into 2.5% each way. I'm just writing that out. So don't worry, it's going to come back. There we go. There we go. I'll try and wiggle that around so that's comfortable for everyone to see. So yeah, basically that's your start of your question. And you just do both of them is the answer. So get your table, do 0 to 20 on the calculator, put in the numbers as I've said them. So n is 20, p equals 0.4. And then look at both ends of the list. Find the first one that's close to 2.5% that isn't bigger than it. That will give you the end point of your critical region on the lower side. Yeah? Yeah? And then the other one, the upper 2.5%, find the first one that's just bigger than the 97.5%. Yes, that's right. The reason why you're going to split it is the value's two-tailed. It's a two-tailed test. Yeah, straight up two-tailed test. And the way you know that is because it's got this beautiful symbol here. Yeah? Okay, so that all right. I mean, I'm gonna level with you both, Kausa and Zero, and the answer is 0. Flat out, it's 0, right? And I can see, I'm holding the book in my hand and I can see the marks. To be honest with you, if there is an issue about this, I'm happy once I've got a calculator that works to go do a full work solution on it, but it really doesn't need one. The answer is 0. So yeah, so you just got to do that in your table. Find the first one that's close to 0.025. Find the first one that's, and that's got to be less than it. This one has to be slightly larger. Has to be this. And those are, and for that, remember, just for that one, add 1 on. So 0.975. So you need to find the one that's closest and just a little bit larger than this, and then add 1 onto it for those, all the same reasons that we did before. That if something is going to be less than on the calculator, we need to turn it into greater than. All right. So it's just a matter of getting the table up and finding both regions, because it's not just one region, because it's a two-tailed one, right? I hope that makes sense. I'm going to hang around there for a minute or two if anyone's got any other questions. Remember, mark schemes are in the book. You've got the physics and maths tutor mark scheme as well, which apparently does have a mistake on one of them. I'm not sure if that's quite true. That surprises me because they're generally pretty good about stuff like that. I will need at the end, so 12:15 or close to, a picture of the work you've done. Alvin, you're not getting notified about this because it's a year 12 stream, but you're more than welcome to join in. I'm not doing any more today. So I'm just going to say to the further maths, watch this one, unless they literally kind of get on my nerves and ask for one. I mean, to be fair, they generally just get on my nerves. But yeah, it is what it is. Can I just do 4A? What do you think I was doing? That's what the board says. I mean, if you ask me to do the mathematics of it, unfortunately, I'm going to have to decline. And the reason why I'm going to have to decline, actually, hold on a minute, maybe I've got a table. Hold on a minute. Maybe I won't have to decline. No, that's a note on my side, I'm afraid. The reason why I'm going to have to decline is my calculator has just died. I can walk you through the process. I'll do that for you now, but I can't do the sums for you right this minute. So let's do this together. Let's just do it. Come on. So we've got x is binomially distributed, 20, 0.4. And we know that we've got 20 events. So what I need you to do is do the list thing on your table. Do we need to do the challenges? If you get that far, I mean, you've only got like 15 minutes left. Who's Marv the greatest? You need, well, reinforcements, or reinforcements are here. You don't get question 4. Cool. Can I just recap question 4 then? Right? Seem reasonable? Again, X is binomially distributed with n equals 20. Oh, Omo, how you doing, my dude? X is binomially distributed with n events, 20, probability 0.4. Is that making sense? H0 could have done without that last comment, my dude. I was going to say that. H0 is probability 0.4. H1 probability is that it isn't 0.4. It's one of those two-tailed awkwardly things, right? So what's happening here? Got a 5% test going on, yeah? But because it's two-tailed, we break it up into 2 parts, 2.5%. I mean, that's not the face I was pulling when I saw that. I believe you that. Half of 5% is 2.5%, yeah? 0.025, 0.975. Hope that makes sense, right? You do the list as before, but this time you're just going to have 2 sets of critical regions, not just one. So you're going to have the normal less than critical region, and also you're going to have a greater than critical region. So instead of doing one critical region at a time, either doing greater than or less than, whatever, you do both of them. Instead of doing it at 5%, you do both of them at 2.5%. So get that table, get that list sorted, and then try and find the number you're looking for in the list. So the first number you're looking for is the first number that's closest to 0.025 but doesn't break it. That is the top end of your lower side critical region. The next number you're looking for is 0.975. You just got to be a tiny bit bigger than that. Pick that number, add 1 to it, and that will be the start of your other critical region, both of those inclusive. I'm sorry I can't do the sum for you, but if you get your table, you should be able, sorry, get the table up on your calculator, you should be able to pick the right ones. Remember, your textbook has solutions, so you can check whether you're doing the right thing or not. All right? I hope that makes sense to those people that are listening. If not, again, post in the comments. We've got 10 people on there. I need some water. I'm not going to edit this live stream because last time I edited it, I lost all the live chat. So that just bear in mind the first 2 minutes are going to be waffling. Now the video starts working. As I said, I'm going to keep it up, this one anyways. Just remember the first minute or 2 is me wiggling around with a whiteboard. No, absolutely not. The critical region, that's the opposite of the critical region, Rashida, right? Because that's the region where you accept. Would you want me to go over? I mean, you can't leave it on a cliffhanger like that, Zara. You need to explain it. What do you want to see again? Okay, one more time. X is binomially distributed with 20, 0.4. I don't think the table is going to be a problem, is it? Can everyone at least have the table sorted? Do you know how to do the table? I mean, part B is a bit more. I said, I can't really do it without a calculator. I can tell you what to do. So if you pick up a pen and a calculator now, I'll walk you through the whole thing. You need help with 9B? Okay, cool. So if you've got a pen and a calculator, I'll walk you through this. Omar, I'll have a look at 9B just after I've done this one. It's like I've got 4 on the board. Okay, how do you do the table? Thank you, good question. Are you comfortable with the idea that from this question, you get X is binomially distributed with 20 and 0.4? So basically this guy. Are you happy with that concept? Yes, no, maybe. I mean, Demetrius, thank you. Can you, so yeah, you're happy with that? Everyone can do that, good. So you go to 7 on the menu, which is the, what's it called? Distribution. You want to go to binomial CD. Right, okay, pick up your calculator, Morse. Okay, physically hold it. Give it a pat on the head. Press menu, go to 7, press down, because the option you're looking for is not there. You're looking for binomial CD. All right? Everyone done that. Now, you know you've got up to 20. How comes? Because n is 20. So occupy yourself for the next minute or so by typing in 0 to 20. While you're doing that, I haven't actually got anything else fun to do, so I'm just going to look at the screen. I'll tell you some jokes if you want. So what you're doing right now is typing in numbers from 0 to 20. I'm just going to have a quick look at 9, whatever the hell 9B, wasn't it? It's the same damn question, my dude. X is binomially distributed with 25 and 0.2, all right? That's all you should need from that. When do we know whether the critical regions are that? The critical regions will never be the second inequality you posted, ever. Yeah? Unless it's a one-tailed test. Actually, hold on a minute. No, that's not true, actually. I thought I sort of misread what you're saying. Alvin, here's how it works. The first bracket is an example of when you've got a two-tailed test. Well, hold on a minute. What the hell are you even asking here? Critical regions are X is less than. Why have you put M in there? What the hell is M doing in there? Who is M? And M. What are these letters? What are you trying to say? Okay, look, if it's a one-tailed test, you're going to have one critical region. If it's a two-tailed test, you probably have two critical regions. Let's just leave it at that, right? Does that seem reasonable? Because I'm not sure what kind of crazy notation you're trying to pull out here, yeah? So I'll restate that for you, Alvin. If you want critical regions for one-tailed test, there'll be one of them. So one-tailed test, two-tailed, two tests. Well, I'm sure M is a number. Right, press equals and type in 20 and 0.4. And you're going to get, eventually, it takes a little time because the calculator is a bit dopey, but you'll get some numbers. You get some probabilities, right? Let me know when you've got them. Excellent. Cool. So you had a 5% test, but it's a two-tailed test, so we split that in half. And you get the values 0.025 and 0.975. There you go. And then all you're doing is two one-tailed tests. That's why it's a two-tailed test. 2 times 1 is 2. The first test is be as close as you possibly can to 0.025. Huzzah. Done. Yeah? Find that number. Okay? That number and everything below it is your first critical region. Yeah? Again, I'm sorry I can't do this. My calculator is just dead. All right? Oh, I've got a message. Okay. Oh, from Dan. I'll deal with that after the live stream. Right, so you found, hopefully, the lower end. Can you type in what it is? Because remember, I haven't got a calculator and I'm relying on you to do my sums for me. Okay, so what is the first probability that's close to 0.025 but isn't it? Right. I'm still waiting on a response on that one. I need to know what the probability of that is. So pick up, have a look at your calculator. That's it, brilliant. What? Neither of those are the numbers I'm looking for. I am looking for a number that says, okay, which is the closest one to 0.025? Read along. What number is it? Is it 0? Is it 1? Is it 2? Is it 3? Is it 45 million? Well, it can't be 45 million. It's some number less than 20, right? That's the number I'm after. So you find the probability that's closest to 0.025, yeah? And then you tell me which number that belongs to. So it might be 2. There we go. Dante, you understand things. Excellent. Well done. We're making progress. So your first critical region is X is less than or equal to 3. Well done, guys. We're getting somewhere. Good stuff. Good stuff. Good stuff. So X is less than or equal to 3 is your critical region. And you know what? Let's check that. Because there's no reason to disbelieve it, but then, life's like that. So that's number 7B. And yes, we've got it. Well done. Part 1 done. Part 2 slightly harder. I want you to find the probability that's closest to 0.975 has to be bigger than it. So be clear on that. Has to be bigger than it. And what number belongs to. Yeah? So look at your table. Go scroll down your table. Find the one that's closest to 0.975. Right? And I'll sit here twiddling my thumbs while you do that. Yes, my dude, I've literally just told you what to do. Brilliant, 12, yeah? But that's the probability of being less than. And we don't want less than. We want to be greater than this time. Yes, Dante, well done, Harley. Brilliant, genius. So we don't want 12 because it's the wrong way around. It's a less than or equals to. So what you're going to do is switch it around by doing 1 minus the probability of 30. And the reason why we do that is not just because the inequality is the wrong way around. Yes, it will be 13 in just a second, is because I don't really want 97.5. I want like the top 2.5%, and 1 minus 97.5, or whatever it's closest to, will give me that, something that's close to 0.025. So 13, x is greater than or equal to 13, is your second critical region. All right. If you just want to keep it at a very, very simplistic level of understanding, just remember whatever number is the first one that breaks 95. This used to be so much harder. What the hell is going on with this board? That. Sorry, this is really embarrassing. You should be able to master the technology of a whiteboard. Clearly not. Right, I think you can now see it. Nope. Yes, now you can see stuff. Good. Sorry about that. That was bad. For flip's sake, why is everything counterintuitive in this whiteboard? Anyways, there we go, right? So x is greater than or equals to 13 is your second part of the critical region. Yes, good. Zeron, that's important, right? Because that, when they say to you later on in the question, when they say to you at question 4, write down the actual significance level of the test, that 0.0211, yeah? Thank you, Omar. I appreciate that. 0.0211, yeah, is your actual significance level, and you're going to need that later, all right? And similarly with the x is less than or equal to 3, find out what the value of 3 is, add that to what Zeron said at 0.0211, and you've actually just done part B, all right? Does that make sense now? I mean, it was hard work, you know, because that's a two-tailed critical region test, and that is quite hard. So you can't see the people in front of you. You've actually done a fair bit of a job. It now's telling me my connection is unstable. I'll find the person who else who dares use the internet in this house and blow them up or something. Any further questions? So at the value of 3, add the probability value of 3 to 0.211, and you've got the answer to question part B. Yeah, you good now? All right, cool. I'm going to hang around here for another 3.5 minutes. I'll give you all the way to 1/4 past. We'll do it like this next time. I'm going to try and get one of those plastic sheets that you can just write on, because this whiteboard business is a bit of a sticky one. I'm not going to lie. I mean, I don't know why I didn't do that in the first place. That's literally just come to me now. I wonder if Amazon still delivers. We'll find out.